Welcome back again. You came back again, or maybe you didn't again. I do care really. If you're here, thank you very much. We're moving on now into the colour world. We're thinking in terms of how computers work with colours. This is a lead in to a product we're going to make. But before we do that, a little bit about the story so far. Many years ago the earth cooled, then the dinosaurs roamed. They were made into That's actually the beginning of a very old joke that wasn't even funny then. I'm going to move on and just talk about the story so far as this course is concerned. Basically, we know that an XNA program is a thing that contains data, which is stuff that you know, and actions, which is stuff that you do. As far as the game is concerned, there's two things a game can do. That's draw, which is put yourself up on the screen, and update, which is move the world on a bit from last time. Now these are both, as far as XNA is concerned, put in as XNA methods. And another programming thing we learned last time is that a method is a block of C# code, a lump of C# that does something with a name. The other thing we learned was that 60 times a second, when the clock goes tick, update and draw are called by XNA, so that this is happening for you automatically and by magic. All you have to do to make your game fly is decide what you want to do every 60th of a second and actually make that happen. We can actually make an empty XNA game that contains a draw method, and all that does is called clear and say make the screen blue, in fact cornflower blue please. And if we're feeling artistic and adventurous, we can change this color if we wish. So that's where we are. We know we write programs to control games, we know that games have to be drawn and updated, and we know that this is all tied into this magical C# language, of which we are learning more each day and loving every minute of it. So moving on now, what we're making, we're going to make a magical mood light. That's a mood light that's magical. You can set it to any color you like. Now you can probably pick one of these things up for, I don't know, about 50p in a pound shop, which sounds wrong to me actually. That can't be right, but anyway, maybe you get two. You can set the color of the light according to your mood, and having done that, we're going to sort of then start making a light which changes automagically over time, so that as time goes by the light runs through a series of tints and hues. And we're going to do this to learn really how it is that XNA programs actually do their stuff and how games work. I don't like doing things that are tough. It sounds a bit hard. Standard programming technique is basically to knock your program down into a series of smaller jobs and then do each one and work through. So we're going to take 3 steps to get to our mood light. We're going to find out how colors work in the XNA environment. We're going to make an XNA program that contains color data, and having done that, then we're going to make the data change over time, and that should, if we do it right, make the colors change over time as well. So the first thing we have to do really is find out how the colors work. Our program needs to work with the value of a color. Now at this point we're trying to separate out what C# is, which is this language that lets you write programs, and what XNA is, which is this framework that uses the C# language to make games work. C# doesn't know anything about colors because it's thinking purely in terms of numbers, strings, floating points and all kinds of other good stuff, and it doesn't really have anything specific as a color built in. But XNA does have this built in, and that's what we're going to use. Before we do that though, we're going to have some fun actually seeing how colors are actually stored on a computer. And to do that, I've got a little bit of demonstration here, which is my color creator program. Now if I press these magic keys, that one, this is my program that makes color. If I actually start it running, it looks kind of boring. There you go. Now what this is showing is how much red we've got, how much green we've got, and how much blue we've got. Now this program, which I'll put on my blog, 3ws.robmiles.com, so you can download it, run it on your PC with your gamepad, just looks at the gamepad and goes, oh, he hasn't pressed anything, I'm doing nothing. When update sees a button going down, I am now pressing blue. The amount of blue in the color goes up. If I want to add a bit of green, hold on the green button, amount of green goes up. If I want to go bonkers and add some red, red goes up. So what I'm trying to show you here, if only you could see the gamepad, is that a color is made up of three numbers: the amount of red, the amount of green, and the amount of blue. And what you're seeing on the screen now is the color you get with 146 reds, 164 greens, and 196 blues. I increase the amount of red in there to make it redder, and it will get redder. If you wish, you can regard this as a kind of universal paint pot, in that effectively I can get every single color in the universe out of this just by pressing down the buttons on my gamepad and actually increasing the amount of red or green or blue that's in there. As far as learning how XNA programs go are concerned, what I'm telling you here is that computers, which love numbers, computers and numbers go together like peaches, and a thing that goes with peaches really well. Aha! You see, that's what happens when you're in the middle of recording something and a man turns up and knocks at the door. You may have probably guessed that I'm not actually recording this in a highly expensive recording studio with soundproof doors and technicians and people in white coats. Actually, I live in fear of people with white coats. I'm recording this upstairs, and it's the morning, and people are coming and knocking on my door and delivering things and saying hello and stuff, which is very nice. But yes, if you spotted the jump, then well done. I'm here pressing buttons and making colours, and as you can see, I can change the amount of colourness by changing the values that give me the intensity, if you like, of each colour. So I think we've seen enough of that. I'm going to trip back to the presentation now, if I can find it. There it is. So as far as we're concerned, we can look at the colour as a thing which is made up of three numbers: red, green and blue. And the bigger the number, the brighter that particular colour. Our mood light will actually work by playing with these numbers, creating colours and then making them change over time. When you use a computer or indeed a digital camera, what ends up being stored inside the computer or the camera or whatever to hold the colour of a pixel is basically a red value, a green value and a blue value. And I'm sorry if I sound a bit breathless, just run up and downstairs twice. Hard work this. Moving on. Okay, so as far as we're concerned, there's one other thing I want to mention though, which is magical, and this is a real power. If you can get the head round this, it's tremendously useful. XNA knows all about it, so do the better computers, and this is transparency or alpha. This is another magical value which you can add to a colour, which says how much colour underneath shows through. How transparent am I? Okay, I have another demonstration which actually lets me show this, and so what we'll do now is have a little look at that, I think. So if I go into here, Color Cyber Trans, this code, same kind of thing. I mean, you can see the code inside if you like. The most important thing here is if I look and it says that I'm basically pressing the X, B, A or Y buttons, I can change the amount of red, blue or green. Sorry, I got that wrong way round. But if I press Y, I change this alpha component, which gets one bigger. Okay, so this is your first look actually at a real program. I'm reading the gamepad, and the X button, which if you look at the gamepad is actually the blue button, presses blue button down, we get more blue. The B button is red. Press the B button down, we get more red. Press the A button down, we get more green, because the A button is green. If we press the Y button down, which is yellow, we get more alpha. So what does it mean if you get more alpha? Let's have a look, run the program and see what we get. Okay, this one has my funky star field, which is funky and a star field. If I press the amount of red, whee! But you don't see anything. Where's the red gone? That's because this value here, my alpha value, is 0. If I start increasing that, ooh, it slowly appears. And the bigger the alpha, the less transparent the thing is. So now if I add some blue, then my image goes towards the green. That's actually adding green actually. So that would tend to figure, oh, I've just had I'm having a hard day. If I add some more red, it gets redder, and so on. But what alpha lets me change is how transparent a color is. In other words, how much of the back shows through. Now you can't do this when you're using pots of paint and things particularly easily, but in computers it turns out to be really quite simple for the hardware to manage this. Now this is the key to how computers make things fade in and out. If you wondered how to make an image fade in slowly, then in XNA, dead easy. Just draw the image and slowly increase the alpha value, and it'll get more and more opaque and slowly fade in. This is how it's done. This is how video processing works. It's all done with that magical alpha value. So as far as XNA is concerned, if you want to, you can make a color up out of 4 numbers: a red number, a green number, a blue number, and an alpha number that says how transparent you are. We'll play with this later. It's incredibly powerful, this transparency management. So I'll make that go away, and the program will now stop. I'll now go back to my presentation, and we can think in terms now of basically a color as far as XNA is concerned as being red, green, blue, and how much shows through, which is almost poetic but not quite. And there's the demo which you've just seen, which is very nice. And then this down here shows you what you get with 227, 159, 156 and 155, those magical mystical numbers that mean so much. Okay, colors, right, fine, got it sorted, even got some clip out of a paintbrush. 4 values for red, green, blue and transparency. So that's what we know the computer's doing. Now we have to figure out how XNA actually does it. As far as XNA is concerned, it makes use of a feature that's part of C#, which is that you can create things that hold information and you can put them into boxes. And as far as the computer is concerned, each box has a particular type. We have this too. I have a camera case. I put my camera in it. I don't put my car in it, my children in it, or my packed lunch in it, because it's a camera case. The type of that case is it takes cameras. Okay. C# has a similar kind of thing built in, and one of the types of box it has is called color, and I can put colors into the color type because that's what it's for. I have another type for numbers, which is either integers or floating point. I have another type for strings, and so on and so on and so on. But XNA has built on this and said, okay, I'm going to make a new type called color, which will hold color information. And so I can make variables of this type. A variable basically meaning an instance of a box of that type, and I can put things in it. It holds the amount of red, green, blue and alpha as integers. So as far as underneath the bonnet or underneath the hood, if you're American, is concerned, when you look inside what the color gives you, it really gives you 3 or 4 numbers: red, green, blue, and how much you can see through, if you like. We can pull those out and twiddle them, and we'll be doing that in the programs a bit later. But as far as we're concerned at the moment, the bottom line is that the color type is the thing that holds the color of the actual pixel of the light we're actually shining. Okay, so we know a program can contain real world information, and one of those things is the color type. This holds the color in terms of the amount of red, blue, green and transparency that the color's got, and transparency controls how much of the image underneath shows through, which is nice. So, bit of true and false to round off this little short presentation. Colors on the computer are made up of red, green or yellow. Is that true? No. Red, green and blue. Yellow, I think, is made up of red and green. Now at this point there's 2 different ways you can view colours in terms of paint and the way the primaries work, and transmissive and reflective and all kinds of hard things. I don't know anything about that because I'm not an artist, but I do know that in XNA and on all computers it's the amount of red, it's the amount of green, and it's the amount of blue. If you're printing, you're buying cyan, magenta and yellow inks because that's the way printer inks work. But if you're using a computer to put things on the screen, you're using red, green and blue. And there's probably all kinds of artistic reasons for this, but I know naught about that because actually I'm a computer program. Okay, so there you go. Grey is a transparent colour. No, it's a boring colour. But it isn't a transparent color. It's just a color that you could make transparent if you want. C# contains a color type. Now if you've been listening carefully, and why would you, then you'd know that C# does not contain a color type. That's down to Mr. XNA. C#, if you like, provides a whole bunch of rails and things that you can extend and put other things on top of. And so while the C# language gives you a whole bunch of stuff, it also gives you a means by which you can make your own other things to put on top of what C# gives you and do even more. Computer memory is made of boxes. No. It's actually, well, we don't really know how it works. It works by magic. You can think in terms of pixies writing things on bits of paper if you like. As far as I'm concerned, it's just stuff you can put things that has a name, and if you use that name, the same thing comes back. And the final one, can you see a pattern forming here? The color type does not contain a brightness value. It just contains the amount of red, green and blue. When you're twiddling your levers editing your home photos in Photoshop or something like that, you might well be moving a brightness slider up and down. But what you're doing in that situation is just moving the amount of, increasing the amount of all the colors at once. So pushing the brightness thing up increases the red, green and blue together. And because they go together, it just seems to get brighter. So there you are. Thank you for paying attention. That's gone completely black. Oh, isn't that scary? Ooh. Anyway, I'll be back next time with even more. We'll start writing some code that fiddles with our colours. Until then, bye-zy-bye.